Chapter 9, Circles. Today we're going to cover Section 9.4, Arcs and Chords. Your class opener. Your objective for today is to apply theorems about chords of a circle. Theorem 9.4. In the same circle or in congruent circles, we have two things happening. One, congruent arcs have congruent chords, and two, congruent chords have congruent arcs. So almost saying the same thing, just in the reverse order. So number one is saying, if I told you that arc AB is congruent to arc BC, then I would know that chord AB is going to be congruent to chord BC. And the second one just says it in the reverse order. So if you start off by telling me that the chords are congruent, then I know that the arcs are going to be congruent as well. Theorem 9.5. A diameter that is perpendicular to a chord bisects the chord and its arc. So if I look at the figure to the right, I see I have a diameter. It's perpendicular to a chord, so I know that the chord is bisected, so I know it's going to give me two congruent pieces. And I also know that the arc gets bisected and gives me two congruent pieces for the arc as well. In the diagrams that follow, O is the center of the circle, and we're trying to find some various pieces. So let's see for number one. I'm trying to find how big is xy. Well, if I look at the problem right now, I'm going to focus on just finding this distance my and realize that if I just double it, I'm going to get the distance from x to y. So I could do Pythagorean theorem and go in here and figure out 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25. Subtract off the 9, x squared equals 16. Take the square root of each side, and x is 4. So I know that just this part from m to y is 4, so xm is also going to be 4. So my total distance from x to y is going to be 8. Looking at number 5, I'm trying to find how big the measure of arc BC is. And I notice since there are 3 chords the same size, I'm going to end up getting 3 arcs the same size, and BC happens to be one of those. I know a complete circle is 360 degrees, so if I take 360, subtract the 120 that I have for AD, I end up with 240. And then if I divide that 3 ways between the 3 arcs that are left, I end up getting 80. Number 1, let's find the measure of arc RAT. So if I look over to the right, the arc that I'm really looking for goes from R to A to T, which is that big. So I'm really just thinking if I could figure out the arc that's up here at the top and subtract it from 360, I'll end up with the arc that I want. Well, I noticed that ST is also going to be 60 degrees because I have a diameter perpendicular to chord RT, so it's going to bisect the arc out there. So now I'm really just taking 360 minus 120 and getting 240. Number 2, what does RT equal? Let's look and see what we have to work with. Looking, I see that RT is cut in half, so if I can just find the value of MT and double it, I know I'm going to get RT. The other thing is that's helpful is I see that arc RS is 60, so arc ST is also going to be 60, which means I have a central angle of 60. I have an angle out here that's 30, so I have a 30, 60, 90 triangle. When I have a 30, 60, 90 triangle, I tend to remember there's a shortcut. I always tend to imagine doubling the 30-degree angle out here. So how can I get from 8 to the part that I want? Well, if OT is 8, then OM is going to be 4. And if I go from there to the piece that I want, I multiply by the square root of 3. So x is going to equal 4 square roots of 3. I need to double that to get the whole distance from R to T, so RT is going to be 8 square roots of 3. Let's look at number 3 down here. So number 3, if AC is 14, so from A to C is 14, then OD is how big? Okay. Well, if I look at this one, I know if from A to C is 14, A to D is going to be 7. I'm trying to figure out OD, so I'm going to call that X. I could use Pythagorean theorem if I knew how big AO was, but I noticed that OT is a radius of 8, so AO is a radius is also going to be 8, and now I can just do Pythagorean theorem. So doing Pythagorean theorem, I get x squared plus 7 squared equals 8 squared, x squared plus 49 equals 64. Subtract off 49, and I end up with 15. Take the square root, and I can't simplify the square root of 15, so my final answer is just square root of 15. Theorem 9.6. In the same circle or in congruent circles, chords equally distant from the center or centers are congruent, and congruent chords are equally distant from the center or centers. So if I look at the diagram down to the right here, what I'm noticing is this. From O to D is 9, from O to E is 9. Since they're both 9, it's telling me that AC and HF are going to be the same size. Or if I had this in reverse, if I told you that chord AC and chord HF are the same size, then I would know that the distances from the center would be the same. So a problem here. Number 4, if the measure of arc AH is 140, the measure of arc CF is 50, find the measure of arc AB. Well, here's what I'm looking at. I'm trying to find the measure of arc AB. So let me just call the measure of arc AB X. Well, I know that BC is also going to be X because the chord is perpendicular to the radius. Well, it's the same size as these pieces down below because that chord is the same distance away from the center. So if I sort of make a big equation out of this, I know that everything added together is going to total up to 360. So I notice there are 4 X's plus a 140 and a 150 add up to 190. And it all has to add up to 360. So subtract 190 off of each side, and you get to 170. Divide by 4, and 170 divided by 4 is going to be what? So you end up with 42 and a half. Number 5, so let's clear out some of this information. So for number 5, if AC is 18, and I'm just going to fill it in right away as a 9 and a 9, how big is OH? So down here I'm looking for how big is OH? Well, I know that AD is going to be the same size as the HG down below, so that's going to be a 9. So now trying to find a value of X, I notice that this is a 45, 45, 90 triangle because the two sides are both 9. So if I go from a side to the hypotenuse, it just gets larger by the square root of 2, and I get 9 square roots of 2. This problem is similar to number 9 in the assignment. So filling in the information. HF is 18, and I'm going to write it in as a 9 and a 9. OE is 12. OD is 10. And I'm trying to find out AC. So I'm really trying to figure out what's that distance up there. So I'm going to start by drawing in some triangles. Up at the top, I know if I drew in OC, if I could figure that piece out, I could just do Pythagorean theorem between that 10 and this piece right here. And if I could do that, I'd be able to figure out my value. But I don't know what OC is. But I do notice that OC is a radius of the circle. And if I draw in OH, if I could figure out that piece, I know that it would be the same value and I could transfer it up to OC. So I'm going to do Pythagorean theorem down here in the bottom between 9, 12, and y. So 9 squared plus 12 squared equals y squared. 81 plus 144 equals y squared. 225 equals y squared. Square root each side. And y equals 15. So I know that y is 15. Well, then I know that OC, which is also radius, is going to be 15. And now I'm going to do Pythagorean theorem for the triangle up on the top. So now I'm going to do x squared plus 10 squared equals 15 squared. X squared is x squared, 10 squared is 100, 15 squared is 225. Subtract off 100. Square root each side. And then let's see, square root of 125 I can split into square root of 25 and the square root of 5, which is going to give me 5 square roots of 5. So I know that my piece right here, x, is 5 square roots of 5. But if I want to get AC, I need to double that answer to get all the way across. So I'm going to get 10 square roots of, and your closure. Right, 2 possible test questions for this chapter.